Hello Math 1325 students. Let's begin Lesson 11, Antiderivatives, or some other people may call indefinite integrals. They mean the same thing. So far we had been studying differential calculus, that is, calculus associated to derivatives. Remember, we had been studying derivatives, how to calculate the derivatives, properties of derivatives, applications of derivatives, and so on and so forth. Now let's go backward. Let's consider antiderivatives and antidifferentiation. And if we have time, we're going to consider applications as well. But first, let's take care of some terminologies. Let's begin with our starting function f of x, and let this be the derivative function of capital F of x. Remember, math is case sensitive, so small f and capital F are two different functions. This is the original function, the starting function, and that's the derivative of this capital F of x. Now, if we re-express the same thing in terms of capital F of x, we can say capital F of x is an antiderivative of small f of x. Antiderivative or indefinite integral. So far so good. Capital F to small f, derivative. Small f to capital F, antiderivative. Or indefinite integral, just one more term. So far so good. But your trouble begins from here. We say capital F of x is an antiderivative of small f of x and denote like this, but oh boy, look at this notation. What is this? Let's analyze this a little bit further. This expression is the same as this right-hand side. F of x is a derivative of capital F of x, which is basically this one here, which I'm highlighting in blue. And this expression here, which I'm highlighting in red, means this. Come on. Yep. So small f is a derivative of capital F. Capital F is antiderivative of small f. They mean the same thing, but expressed differently. Here in blue expression, small f of x is the subject of this sentence, and then this equality is the verb, and f prime of x, that's equal to f prime of x, that's the object. Here, capital F of x is the subject, equality is the verb, and the object is the antiderivative of small f of x. They mean the same thing, just expressed differently. Okay, that is one side of the coin. So what does that mean? Now the other side of the coin is the notation issue. This thing here, which I just highlighted in blue. So let's go back to these. I don't need this highlighting anymore. Let's go back to black. Okay, and then this one green, and then this one red. Let's decompose like this, and then we read like this. Integral f of x dx, like this. The first expression here, not the expression, excuse me, first symbol here, that's called the integral symbol, and that opens up this expression. And then the original function, the starting function, and then dx. That closes this expression, okay? Opens and closes. Don't forget to close. I'm afraid I get a lot of students making this mistake, missing this dx. That's incorrect. And each time I take a point off, and they can add up. The worst I have ever had was 13 of those, minus 13 in a single exam. So even if the student would have been getting 100, minus 13, and it drops all the way down to 87. from perfect 100 to just B, from 90 to 77, from A to C, and so on and so forth. Okay, that's a bit too hard, so I usually put a cap no more than 10, but still minus 10 points for this small mistake, missing dx. Well, that's not really small, as a matter of fact. Missing dx is significant. This is very, very important. This is not just a closer. There are two very, very important reasons why this dx is so important. One is this specifies a variable. Here's an example. Okay, let me cook up an example. 3x squared minus 4a squared x. Okay. Suppose if we have something like this. Which is the variable? Is this a function of x or is it a function of a? It's unclear. As a matter of fact, even if there is no such thing here, I mean, even if there is only one character here, you still have to specify your variable. If there are more than one characters, then this dx is absolutely necessary. As a matter of fact, it's absolutely necessary every single time. If you open it, you must close it. But if you have more than one characters, this is really important. And another reason is integration by substitution, which we'll go over a couple of weeks later. And there, you'll see how important this dx is. So missing this dx is no small mistake. By itself, it may look small, so I'm taking just 1 point off, but I'll just let it roll. Another missing dx, another minus 1, another missing dx, another minus 1. I'll just let it roll. So beware. By the way, we have this problem here, so why don't we complete this problem? Let's see. What kind of function will give you 3x squared once if you take the derivative? Well, it's going to be x cubed. And please check, take the derivative of x cubed and you're going to get 3x squared. And then this is going to be 2a squared x squared plus check. Please check. Take the derivative from the right hand side. Take the derivative of x squared. We have 2x and there's already 2, so 4x. Yeah, please check. So this is the integrand. And this one here, which I'm highlighting brown, is the antiderivative function. So here we go. Integral f of x dx. That is the antiderivative function. Oh, by the way, one more thing. This function f of x is called the integrand of this expression. So this expression here, this integral expression here, is called the integrand here. So this is integral symbol, integrand, and then dx. This is a closer. So opener, integrand, and the closer. Among those, what's the most important? Opener, integral is the most important, but I haven't seen many students missing this integral symbol. But I've seen many students missing this dx. This is the second most important. So remember those. Okay, we took care of most of the terminologies and concept, but not 100%, not everything. This expression here is not entirely correct. Not 100%. We still need one more, and that is the integral constant. Antiderivative functions are not unique. There are infinitely many antiderivatives, as you can see from this example. Let's begin with 2x minus 3. That's my starting function, and let's look for antiderivative functions. There are infinitely many out there because let's get this x squared minus 3x, which I just highlighted in brown, and take the derivative. X squared becomes 2x, negative 3x becomes negative 3. Yeah, we get the derivative function here. But then again, arbitrary constant here plus c will just disappear when you take the derivative. So whatever plus c, it'll just disappear, whether it's plus 0 or plus 1 or plus 1 over negative square root of 5, I don't care. Whatever constant will just disappear. And how many constants are there? There are infinitely many. So there are infinitely many antiderivatives. But then again, even though there are so many, they are not uncontrollably many. They all differ only by constants. So if you put plus c, if you put plus c, plus c, if you add plus c, oh, that doesn't sound right. If you put additional plus c, then that'll cover everything. So that'll finally complete the problem. Let's come back here. How do I complete the problem? By putting plus c. That'll complete the problem. By the way, I'm going to be a little bit more lenient on grading this plus c part. Ooh. It's hard to read like that. Yeah, pink is a little bit better. I'm going to grade a little bit more lenient than plus c. Missing plus c, I usually do not take any point off if I'm grading. Of course, if you're working with MyMathLab or WebAssign, those systems will take some points off, so you have to be prepared. But as far as I'm concerned, I'm not taking any points for missing plus c. That's because this is elementary level course. In high level courses, of course I do. As for missing dx, I always take some points off because that's more important, that's more severe mistake compared with missing plus c. I've been teaching in college level since 1994, so I have plenty of experiences and I met a lot of people and I discuss a lot with my colleagues in all over the world. And I've never seen anybody not taking any point off for missing dx. They all take some point off for missing dx. Some of them are really harsh and take half off. Me, just 1 point off. But I usually let it roll. As for plus c, again, most people still take some point off. I'm one of the minority that is being so lenient about plus c. Okay, all right. I'm being a little bit generous about plus c, but I'm not going to be generous on missing dx, so be prepared. Okay, those are notational issues and all those terminologies. Looks like we'd better talk about the derivative rules and antiderivative rules in the next video. So okay, let's stop here and let's come back to section 1 again. See you soon.